Hey, in this video, I want to chat about the Foobara software framework. I'm going to keep things high level and try to focus on what Foobara is and why I wanted a framework like this. And in a separate video, I'll do a code demo. All right, so what is Foobara? Foobara is a framework for building systems that are command-centric and discoverable. Command-centric and discoverable, these are the two pillars of Foobara. And why did I want a framework like this? Well, I wanted a framework like this for dealing with projects with a very complicated business domain. So let's take a look at some code that does not attempt to encapsulate domain logic. So here we have a controller action in a reservations controller for a Capybara Cafe business. This is the create action, and it exposes via HTTP a way to make a reservation. So this code carries out the make reservation domain operation. And the question is, can you see where the HTTP integration code is and where the domain logic is? Well, in red here, I've highlighted the code that looks to me like integration code, and in blue, the code that looks like domain logic. And as you can see, they are blended together. There's no separation of these two concerns in this code. So now let's take a look at a command that encapsulates the domain logic of our make reservation operation. And we are going to expose this through the create action on our reservations controller. Because of that, it might be tempting to just call it create reservation. However, we're not going to call the command create reservation. We're going to instead call it make reservation because that's a more proper name for the business operation. So we're going to try to avoid allowing details of how we are exposing our domain logic to the world from influencing how we are naming our commands. In other words, we want to build a good mental model of our domain in the code base and have it be independent of the integration code. So that's just a small point about naming and mental models I want to make here. And I'll come back to this concept and talk about it a little bit further, but let's take a look at the command. So here we have our make reservation command. It has inputs, which are typed. It has a result, which is typed. We have an execute method, which is an opportunity to write a self-documenting algorithm of what is expected when this command is ran. We have some runtime context, in this case, a reservation entity. We have some error handling. We are creating a reservation entity. And the important thing to point out here is that all of this code is related to implementing the domain logic behind creating a reservation. There is no HTTP integration code here. So how do we run a command? Well, let's go back over to our create action. And we can run our command here with the run method. We get an outcome back, which has a result in the case of success. It has errors in the case of failure. And so now our create action is concerned with exposing over HTTP our make reservation command. And so now all of this code is integration code. So what are some benefits of using commands to encapsulate these high-level business operations? Well, firstly, now the domain concepts are clearly represented in the code. The code is actually communicating the mental model to you now, whereas before it was not. And in my opinion, this is the biggest benefit of this type of separation of concerns. Now, because this is a matter of separation of concerns, you're going to get other benefits that come with separation of concerns, such as code reuse, improved maintainability. Now I wanted to talk a little bit more about naming and mental models. Here I have a couple controllers with some controller actions. These aren't all of the controller actions and certainly not all of the controllers. The create action here we already know is carrying out the make reservation domain operation. And that would have been a good guess even if we didn't already know it. However, the update action, that's a lot more ambiguous. And in my experience, any number of domain operations could actually be carried out by the update action. And often it's carrying out multiple domain operations, depending on what is being passed to it. So let's skip that one and let's look at destroy. I would guess that destroy is carrying out a cancel reservation operation. That is not guaranteed. It could be that Canceling a reservation means moving a state machine from held to canceled, and maybe moving that state machine is handled through the update action, or maybe some other action on some other controller that's exposing that state machine to the outside world, or maybe a custom controller action, such as cancel. That's not very restful to do that, but it's certainly very common. Maybe there's an is canceled flag that we set through the update action again. So probably cancel reservation, but no guarantee. Here we have an index action on a time slots controller. I mean, I'm expecting that to give me a list of time slots. Anyway, let's take a look at what these actually are carrying out. So we already knew create carries out the make reservation operation. Turns out that update is carrying out reschedule. And that's difficult to guess. It's difficult to guess that reschedule reservation corresponds to the update action. We did guess destroy correctly. It is the cancel reservation operation. It wasn't guaranteed, but we were able to guess that one. And it turns out that index is carrying out check availability. Now, it could even be the case here with index that check availability might do a better job of encapsulating the actual domain operation, whereas index might give a list of time slots expecting the calling system to know how to interpret those, which means the calling system would be forced to implement a little bit of domain logic locally, which is not our intention here, or should not be our intention here. And the main point I want to drive home here is that we do have a mapping between mental models. And so if you have a situation where you do not have any representation at all of the actual business domain model, you can wind up in a situation where you're left with the mental model of the patterns chosen to solve the problem in engineering. And this is not specific to REST. Any engineering contrived pattern can have this problem where you might wind up in a situation where engineering has to try to train the business on an engineering mental model. And this just adds to confusion and makes it harder for people to understand the problem trying to be solved, including engineering, and understanding the proposed solution to that problem. And this can actually be a major issue for projects with very complicated business domains. So just wanted to highlight this issue. All right, so getting back to the topic at hand, talking more about separation of concerns and building a command-centric system. Let's take a look at the directory structure here. Here's a directory structure of a typical web application. Now, you can use Foobara to build things other than web applications, but here we have a web application, and we have a blue circle and a red circle to indicate that these files contain both integration code, which is denoted by red, and domain logic, denoted by blue. So we have three different types of integration code going on here. We have HTTP, we have worker queues or scheduling asynchronous concerns, and then we have CLI, we have command line interface. This is where we are exposing domain logic on the command line. And these are all located in these files. Whereas the domain logic, like we mentioned, it's smeared all over the place. And that is a problem if your domain is complicated and difficult to wrangle. So if we introduce commands, we now can hoist that domain logic out into these commands and give a better representation of the business mental model. All of the integration code is still in the same places, but we do have a clear separation of concerns here. Now, I still do not like this directory structure. For one thing, you have commands cohabitating with controllers in the app directory, and commands are doubly nested compared to the rake file, and it's more further nested than the jobs. Just doesn't feel good, and it doesn't feel as command-centric as it could be. And Foobara is going to help us with this, but this is a very natural directory structure for a team that is struggling with this problem to evolve the code base into as they start to make improvements. All right, so that's pretty deep on commands. Before moving on, I did want to give a shout out to the Cypress Mutations gem. Really great gem that implements the command pattern. I've been using it for over a decade in pretty much any project I can use it in. And a shout out to Jeshua, a really great programmer who introduced me to it in 2013. Okay, so again, Foobara, command-centric, discoverable, these are the two pillars. Now let's dive into the discoverable aspect. So what does it mean to be discoverable? A discoverable system can give a machine-readable description of its primary operations and the related concepts they depend on. So this is a formal manifest of data describing the system and its interfaces. Here's an example of some manifest data generated from a command. You can get manifest data from any Foobara concept. This is for a command. You can see we have some information about the types of the inputs to the command. This is truncated. There's a lot more data than this. The point being that this is given to us for free by Foobara. Okay, so what are some implications of this? What are implications of adding discoverability to a system where we've encapsulated the high-level domain operations? Well, let's take a look again at a web application example. Here, we're going to use purple to indicate a mixture of domain logic and integration code. In this case, we have controller actions exposing domain logic to the front end over HTTP. We have jobs carrying out domain logic being invoked by workers and schedulers. We have domain logic being exposed on the command line through rake file tasks. We do know a way to make some improvements here that we've already talked about. A valid way to make some improvements here would be to move towards a command-centric approach where we are encapsulating the high-level domain operations. And in this case here, we now have our domain logic isolated from how we're exposing that domain logic to the outside world. Now, what happens if we introduce discoverability to the mix? Well, if we introduce discoverability, we get something that looks like this. Now, the reason this happens is that once we have encapsulated the high-level domain operations, the controller actions and jobs and rake file tasks, these start to become less interesting and more repetitive. You're generally going to copy and paste an existing controller action, for example, change the command that it's running, maybe change the way that it is converting inputs from one type to the type the command expects, usually in a predictable way determined by the types. And so that starts to become repetitive. And if you have a formal definition of how those translations are supposed to be occurring, you can actually abstract away that integration code. And that's what has happened here. We've abstracted away that integration code. For example, we now have all the information we need to just dynamically create the controller action at runtime. We don't need to write a controller action, and we don't need to test a controller action. So what are the benefits of this? Well, as we just saw, the integration code can be abstracted away. Usually less code is a good thing. The domain logic is less likely to creep into the integration code. In fact, it can't creep into the integration code because there is no integration code. And the mental model is now not only communicated, but dominant in the code base. And I think this is the most important benefit. So here, the mental model is a secret. The system is not telling you the mental model. Here, the system is telling you the mental model. And here, the system is screaming the mental model in your face. The bulk of the code, the weight of the project has become centered around the business domain. And another implication of this, you have less code. This is going to mean faster development and testing. So you don't have to write controller actions anymore, and you don't have to test them anymore. And that's going to result in a faster development cycle. And because of that, even though Foobara is designed for projects with a large, complicated business domain, I would still find it attractive for a lot of small and medium-sized projects because of this increased speed of development. All right, so I did want to talk about some of the other concepts besides commands. So commands are a primary concept. There's also secondary and tertiary concepts. Can you think of another primary concept that might exist in Foobara? Well, that's a trick question. Commands are the only primary concept. So let's look at some secondary concepts. We have types. Two interesting types are models and entities. You can also make custom types. There's a whole bunch of built-in types. There are errors, domain mappers. They know how to map a concept in one domain into another domain. We have domains, which are collections of commands, types, errors, whatever. We have organizations, which are collections of domains. Now, what makes these secondary concepts is that these are units of code that your engineer would be implementing in order to implement the domain. With a notable exception of built-in types, your engineers are not going to be creating built-in types, so that doesn't belong here. But yeah, your secondary concepts, these are things that your engineer is implementing as they carry out the implementation of the business domain. Tertiary concepts, on the other hand, these are going to be things that your engineers use either from the Foobara framework or from some third party. These include things like CRUD drivers. These know how to read and write entities to a data store. Command connectors, these know how to take a command, read its metadata, and expose that command to the outside world in some interesting way. There are remote commands. Remote commands are imported from one system into another. They have the exact same interface as the command in the other system and operate as a proxy to it. This is very important for being able to re-architect and remodel systems over time in a safe way. And there's remote everything, not just remote commands. So there's remote domains, remote types, and so on and so forth. And then also manifest metadata, which we've already talked about. All right, so let's take a look at how these other concepts relate to one another. This is a lot to look at in this diagram, so we'll break it down here. Here we have a generic reservation system. This system doesn't know anything about capybaras. It doesn't know anything about cafes, just knows how to handle reservations in a generic way. Here we have our capybara cafe system. It does know about capybaras and it does know about cafes. And it is going to use our generic make reservation system as an implementation detail. We have a reservations domain. We have a Cappy Cafe domain. We have some other random domain down here. Let's just say for the purposes of this presentation that this is a Salesforce integration domain. And let's dive into some of these secondary concepts, the one that your engineer is writing to implement the domain. So we have make reservation, which is a command. That's actually a primary concept. We've already talked about commands to death. Here we have a reservation, which is an entity. An entity is a type. There's a lot to say about Foobara entities that should probably be its own presentation or collections of presentations. If you've ever worked with an object relational mapper, then you more or less know what to expect here. Here we have a domain, which is a collection of commands and types and errors. Errors are not reflected here, but probably should be. We have an organization. That is a collection of domains. Over here, we have a domain mapper. This is a reservation mapper that knows how to map a reservation from the generic reservations domain into a Salesforce reservation. Maybe we have a custom reservations table in Salesforce, or maybe this winds up being a Salesforce lead down here. So let's consider this a Salesforce lead in our Salesforce integration domain. And our reservation mapper knows how to map from a reservation to a Salesforce lead. Something I want to point out here, something that I think is very powerful that I've discovered, instead of translating something like a reservation into an entity in another domain, it's better to translate a reservation into the inputs into a command in another domain. And this is just one way to make the system even more command-centric. A benefit is that now our command does not need to contain any logic for how to translate from a reservation to a Salesforce lead. So we don't have Salesforce domain concepts in our command anymore. And that just helps, again, with managing domain complexity. All right, so let's look at the tertiary concepts, the ones that are provided by Foobara, or you might use it from a third party, but are not specific to the domain you're trying to implement. So we have command connectors. In this case, these would be HTTP command connectors. They know how to take a command, read its metadata, and dynamically construct a controller action, for example, that can then be used to invoke that command over HTTP remotely. Here we have a remote command. This make reservation remote command has the exact same interface as a make reservation in the generic reservation system, and it can operate as a proxy to that command over the HTTP connector. And we really have remote versions of everything. You can import the reservation type into your system from the other system, so on and so forth. Here we have a CRUD driver. It knows how to take an entity and read and write it to a data store. In this case, we're reading and writing reservation records to a database. A very interesting use case for a CRUD driver that I probably shouldn't spend too much time talking about that would actually move it into the secondary concepts would be if you wanted to use the CRUD driver as a way to abstract away a complicated, poorly modeled database schema. And this is a problem I've ran into on at least two projects where I really wish I had something like this. You wind up over time, inevitably, with a database schema that has a very complicated and incorrect model of the problem and the proposed solution. And you can make progress, and teams do make progress on improving that modeling, but it's very slow. And I think it's usually slow because it's a refactoring effort. So it has to compete with other refactoring efforts. And it's dangerous. It's dangerous to carry out these data migrations safely in a way that doesn't cause downtime. And so you have to also compete with feature work that actually contributes to velocity. And so it's hard to get priority on this kind of a refactor. However, what would be much easier would be simply to write some code in the form of a CRUD driver that knows how to assemble a reservation that might have its data spread across three different tables with poorly named columns. Maybe it needs to translate some of that data somehow and provide the system with a really clean model of what a reservation is. So you are, in essence, abstracting away the poor mental model instead of allowing that mental model to impose itself on the rest of the system and the team and the organization in turn. All right, so getting back to task here, last but not least, we have our end user. The end user is happy because they are able to finally schedule a reservation at the Capybara Cafe. They're going to meet a capybara for the first time. This is all possible because the people who built the system were able to manage the domain complexity and understand the problem they were trying to solve and actually understand the proposed solution to that problem. And yeah, that is it. Thanks for listening all the way to the end. I'll do a code demo in another video, and peace.